All right. Okay. This screen is a little hazy. I don't know why. Yeah, it's better now. All right. Yeah, so much better. So hi for education. How are you? Just a second. Let me just get started with this. All right. So how you guys doing? Hi Pavan. Long time. Hello Srinivas. All right. So first of all, guys, welcome to the Unacademy JEE English. All right, this is a brand new channel by Unacademy, which is India's largest online platform for IIT JEE. And on this channel, everything is being taught to you completely in English. All right. So this is a series that I host for class 11 students, and this is lecture 4 of Newton's laws. Today we're going to talk about Newton's laws and their applications. Little confusing. What is little confusing for education? What is it that you're confused about? So yes, I have noticed that. You get confused very soon. Tell me what is it now? Ah, if velocity is downward and g is also downward, then speed upward. And if velocity is upward and g downward, okay. Good afternoon, Sabrish. Okay, so for education, forget about the direction of g, forget about the direction of velocity. What we are doing is we know that velocity and acceleration both are vectors. Okay, both velocity and acceleration are vectors. So what we are doing is that we are choosing signs to represent the directions of those vectors. Normally what we do is if something is towards right, we take it as positive. If something is towards left, we take it as negative. If something is towards up direction, we take it as positive, and something which is down, we take it as negative. I hope you remember your axes when you're taking y and x axis coordinate system. All right, everything which is right of the origin, everything which is right of the origin. So here you will write plus 1, plus 2. All right, here you write minus 1, minus 2. Here you write plus 1, plus 2. Here you write minus 1, minus 2. That is it. So if velocity is upward, then I take it positive no matter what it is. Will you complete syllabus? When will you complete syllabus? Okay, I don't know. Which class are you talking about? I am hoping that I will complete the syllabus by December. Alright, for education. Is that clear? When the velocity was downward 10, I took it as minus 10 root 2 because it was downward. Then when it rebounds, it is upward. That is why I took it as plus 11th again. So most likely by December. Okay, that is it. That is it. Yeah, you are getting confused about very small little things. Don't worry. All right. So now remember that we are using sign conventions because either a vector is up or down or a vector is right or it is left in 1D. So in 1D I'm using this. In 2D, we use IJK. All right. So without any delay, let's just proceed further. All right. So getting on with this lecture, let me first introduce myself for those of you who don't know me yet. All right. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. And for the past almost 8 years, I've been teaching physics for IIT JEE. And I've taught offline at some of the most prestigious institutes in India. All right, this is my first online venture, again with Unacademy, of course. So more about myself. So I was JEE rank 447, All India rank 447, and All India rank 192 in the two stages of JEE that it was conducted at my time. Okay. Yes, yes for education. Okay. Now I had also qualified NTSC Stage 2 and I was in the top 1% in the NSEP, which is the National Standard Examination for Physics, which you know as the first stage of Physics Olympiad. And while teaching offline, I have already coached many students to top ranks in IIT. Alright, okay, where did this come from? Oh, okay, so let me wait. Okay, this is weird. Okay, something wrong with this. This has only three slides. Wait, let me see what happened. Okay, just give me 1 second, guys. I don't know how this happened. Okay. Okay. Okay, so I'm saving my PDF one more time, exporting the PDF one more time. So just give me a minute. There was some error in the last PDF that I exported. All right. So this is almost done. Okay. All right. Yeah. So this seems fine. All right. So moving forward, let me also tell you a bit about the Unacademy subscription. And guys, this is very important. No. Of course not. Of course not, Pawan. You guys don't get off that easy. Okay. So as I was saying, the benefits that the Unacademy subscription brings you are live classes. You get to interact with your educators. You have live polls and leaderboards. You have test series and analysis, and you have live doubt clearing sessions. Yes, this is what the PDF I wanted to use. This is the PDF made for you guys. That was, I don't know, there was some error there. Alright, so let me tell you, as I said earlier also, I've been saying this. So these two features, are really helpful. They are helping you guys replicate the experience of offline coachings online in today's date, especially. You know, when you can't attend offline classes. So don't worry, Unacademy's got you covered. They are giving you offline class experience in the online setup. Next, you have live polls and leaderboards, which keep your classrooms extremely interactive. You also have test series and analysis. So trust me, a lot of guys are registered on the Unacademy Plus app. So you have a huge pool of people who will be taking this test. So it will give you a great assessment of your own standing in your JEE prep. Next, of course, you have live doubt clearing classes. So this is again very important. I know that you guys are always worried about your doubts. You always have so many doubts when you are starting things for the first time, especially class 11 students. And your doubts hardly get cleared. All right. So don't worry about that. With the Unacademy subscription, your doubts are always taken care of because as a compulsory feature of all courses on the Plus, every fourth session after every three classes has to be a live doubt clearing session. That's a must feature in all Unacademy courses. All right. And plus, on top of all these benefits, Unacademy is giving you access to India's best educators on a single platform. As I said, they are going all across India. They're trying to find the best educators and they are getting them on board. All right. Next, how do you get this subscription? Very, very easy. Install the app. Once you have done that, go to the plus section and select your goal as IIT and click on get subscription. Now, please hurry up while getting your subscriptions because the prices of these subscriptions are going to get hiked from the 10th of September. So, hurry up, get your subscriptions before the prices get hiked. So, what is going to happen? Let's see. So, this is the look at the old prices which are valid only till 10th of September. Valid till 10th. So, you still have a few days. Alright, so please hurry up and get your subscriptions before the prices increase. So you still have, I think, around a week left till you can get your subscriptions at these prices. So in these prices, you will notice that 1 month subscription comes to 6,000. If you use this code RD Live, the cost becomes 5,400. You get a 10% off. Similarly, 3 month subscription comes at 15,000, which after using RD Live would become 13,500. So please, I will pass out JEE exam. I will come and meet you. You are always clearing my doubt. All right. So why don't you try and join a regular course with me? All right. So 6 month subscription comes to 24,000, which after discount would be this. 1 year subscription again. These are the two main subscriptions that you guys should be aiming for, either 12th pass students or 11 students or 12 students. All right. So 12th pass and 12 students should be going for this 1 year subscription, which will come currently at 30,000 after discount. It will be after 10% off. If you use RD Live, it will become 27,000. And for class 11 students, this is what you have to pay for 2 years. For 2 years, imagine. Uh, in my offline experience, I have noticed that students pay some 10 to 15 times this, okay, 10 to 12 times at least this amount. All right, sometimes even more. So you're getting quality content, best educators in India at these prices. I think you shouldn't wait and get your subscriptions. This is coming at around 2,200 a month. All right, and imagine this is coming around what, around 1,300 a month. So it can't get better than this. 1,300 a month is nothing. I mean, people pay, from what I've recently learned, people are paying 4,000 for their class 4 tuitions, up to 8,000 for their class 7th 8 tuitions, and for 9 10 tuitions, okay, home tuitions for school, they're paying 10,000 per month also. All right, from class 9 10th onwards, they're paying 10,000 or more per month. So these prices, you're getting professional guidance for IIT JEE, which trust me, it doesn't get cheaper than this. All right, so definitely go ahead and get your subscriptions because after 10th, this is what the prices are going to look like, and even at these prices, these subscriptions are, trust me, way cheaper than anywhere else, than the fees that you might be paying anywhere else. All right, so look at this. The biggest price hike would be in the 2 year plan. It goes up from 36,000 to 56,000. And similarly, 1 year plan also goes up by almost 10,000. So these are the prices that you will have to pay after 10th. All right. Hi, Yogi Aman, how are you? All right, so if you haven't gotten your subscriptions, please go ahead and get them before 10th. For class 11 subscriptions, you are saving almost 20,000. So why do you want to waste more money if you can get the subscription at such a cheap price till 10th? Go ahead and get your subscriptions. I hope you know that even for these prices, you have no cost EMI options of payments. All right. So I am very late for this subscription. It is best. I'm not able to attend live lectures daily because my many chapter is already covered in it and many chapter is remaining. All right. So first of all, for education, the JEE English team has not yet started the courses. All right, we will be starting the courses, so we will take them up from the starting topics again. All right, I would be taking up kinematics once more. All right, from most likely from 15th of August, 15th of September, most likely. All right, so don't worry, you're not too late. And whenever you're getting subscriptions, please remember to use this code RD Live. This is the code that will give you a 10% off, no matter what the price, whether it's the old prices or it's the new prices. All right. For those of you who are following us on the JEE English channel, you can connect with us on Telegram app with the help of the link shown above. All right. So enough of that. Now, why don't we get started with today's discussion, which is about Newton's laws. So last time, okay. So by the way, yes, this is what I wanted to. Okay, you do that. Trust me, at 13.50 a month, it is definitely worth it. And for payment options, you have the no cost EMI option also. You don't have to pay that entire amount also in one go. You can break it into monthly payments of 13.50. Okay, you won't be charged extra. That is what no cost EMIs are. All right. So in the last lecture, we talked about Newton's laws. Okay, so this is something amazing. This is actual photograph of the paper that Newton presented. This is what the name of that paper was: Philosophia Naturalis Principia Mathematica. So that is natural philosophy's mathematical principles. All right. So he said that he's describing mathematical principles for laws of nature. All right. So if you can see, this is, you can see here, author is Mr. Isaac Newton or Sir Isaac Newton. All right. So this was actually printed in 1686. This is after the presentation. I think the presentation happened in 1676. This is later when he came out with the copy. Hi Vineet, how are you? All right. So now, last time we talked about the three laws. Okay, I talked in detail about the first law, in detail about the second law, but I actually thought that I should be discussing some more examples of third law because students always remain confused about that. So, what is third law? Third law says every action has an equal and opposite reaction. So, you see here, if you are pulling this rope, all right, if you're pulling essentially this wall with some force, then the wall is also pulling the rope to itself, and that is what you can see from a weight measuring thing. All right, it is as if somebody was applying a force. So if you are pulling an elephant, the elephant turns out is also pulling you, which you can see here. If you see the forces here on the scale, it is being pulled from both the sides. All right, so it's not only this guy who's pulling it and this guy who's doing nothing. Both are pulling it. Second, you must have noticed this: when a swimmer is trying to move forward, how do you do that? You push the ground. You push the ground backwards. So if you push the ground backwards, you end up moving forward. Why is that? When you are pushing the ground backward, the ground is pushing you forward. That is something what happens when you're walking also. Hi, Sylvester Solomon. When you're walking, what are you doing? You are trying to push the ground backward and the ground is pushing you forward. All right. So this is everything is third law. Similarly, again, force on finger in the wall. If you ever try punching a wall, the harder you punch it, the more hurt you will feel. That is because when you are putting the force on the wall is also applying a force on your hand. All right, so that is also third law. So, but please remember a few things about third law. Third law, the forces are always equal and opposite. However, these forces are acting on different bodies. So, if the wall feels a push backward, the swimmer feels a push forward. So, if the action is taking place on one body, the action always takes place on another body. If you are pushing the wall, if wall is feeling this action, then you will be feeling the action. the same body never feels both action and reaction. Remember that. And their directions are always opposite. Their magnitudes are always equal, and their nature is always same. I told this last time. So when you talk about a block, if the block is exerting a force of normal reaction on the ground, then the block feels a normal reaction only upwards. Alright, so when a block is kept like this, the block is pushing the ground downward and the ground is pushing the block upward. These are action reaction pairs. So reaction of normal will only be normal. Mg is not the reaction pair of N as a lot of students think. Similarly, when you will study about friction later. So when this is moving forward, the ground applies friction on this backward. Alright. And if the ground is applying friction on the block backward, the block will apply friction on the ground forward. Now these two frictions are action reaction pairs. So please remember, the reaction for normal will always be normal force only. The reaction for friction will always be friction only. Is this 2022 batch? Yes, yes, Vineet, this is. Alright. Similarly, again, when you're feeling mg force, okay, so when the ground is pulling the block with the force mg, when earth is pulling a block with the force mg, actually speaking, the block is also pulling the earth towards itself for with mg. Alright, so please remember that this also happens. That is also very, very interesting. So if you had a ground and if you had a block kept here, so block is hanging in the air. So if block is feeling a force downward of mg, trust me, the ground is also feeling a force upward of mg due to the block. Alright. So when you are standing on earth, when you are jumping, in fact, suppose when you are jumping, in fact, you will also realize when you are jumping, you are pushing the ground down, the ground is pushing you up. Technically speaking, when you move up, the ground also moves down. Alright. We will talk about that later. Why don't you see the ground move down? Actually, every time you are jumping, you are actually pushing the ground down. Okay. We will talk about that later somehow. Later though. Now some very, very important points about Newton's laws, which again should be very, very clear. I already discussed these in the last lecture. I'm still reiterating them. So first is the Newton's laws were only defined for point masses. So please remember this. Newton in fact defined all his laws for point masses only. You should know. In physics, most of the laws that we will talk about are only defined for point masses. Okay. So what is a point mass? So let's talk about that also. What is a point mass? This is a hypothetical mass, a hypothetical object having no volume but has mass. Having no volume but having a mass. So hypothetical means imaginary. Alright. So you imagine that there is a mass which is essentially a point. That is a point mass. There is a body which has no other dimensions, which has no thickness, which has no length, which has no breadth. So you can represent the body with a single point. But this point has a mass. That is what a point mass is. Now obviously it is an imaginary concept, because you guys should remember from your definition of matter that everything that occupies space and has mass is called matter. So, hi Deep, how are you? So obviously, such a thing cannot exist. If you have mass, you have to have volume, right? You cannot have mass without occupying space. Alright, all matter occupies space. So obviously, this is a hypothetical concept. This is an imaginary concept. Okay. So, but this law is defined only for this imaginary mass, which can be represented as a point. Alright, please remember this. As I discussed this in the last class also, when you're talking about velocity, when you're talking about acceleration, you can only define those things for points. Only a point, let's say this point, can have a velocity, can have an acceleration that can be defined. Alright. Now if the entire pen was moving like this, imagine. So it's moving like this maybe. Now what is the velocity of the pen? You can't define a single velocity of the pen because the pen is not a point. You can define velocities of points. You can talk about distances traveled by points. When this channel is created, okay, so it's been a while. It's been almost a month. Okay, so that is what you need to remember. For bigger objects, you cannot define a single velocity. Alright, because different points on this again are moving by different distances. If everybody is moving with different distances, then every point on this pen would have different velocities, may have different accelerations. They may also have the same velocities and accelerations in one special case if it goes like this. Except for this case, in general, you cannot talk about one velocity of this pen. Alright. Especially imagine if this part was taken apart and this part is moving with another velocity. Now again, even if both are moving with constant velocities, then also I cannot define one velocity for these two. Okay, so please remember this, that all our analysis, all our definitions are only meant for point masses. Okay. Next, we discussed this also the last class, that Newton's laws can only be applied in inertial reference frames. I talked about inertial reference frames, that inertial reference frames are those in which the law of inertia holds true, and the observer of an inertial reference frame was called an inertial observer. The observer of such an inertial frame would be either at rest or would be moving with a constant velocity. So these are the only two types of observers that are inertial. Either if an observer is at rest, again now when I say rest, now I mean absolute rest, by the way. It is not relative to anybody. If an observer is at absolute rest or moving with an absolute constant velocity, then those observers are inertial. Now, of course, there is a problem. The problem is, how do I even know if somebody is at absolute rest? I told you in the first class of kinematics that you can never predict, you can never comment on the state, absolute state of motion or absolute state of rest. Why? Because all motion is relative. So even when you are looking at things, all you can predict is what it is doing with respect to you. You can never realize whether that thing is moving or not. Alright. So this is again a problem area. We imagine, okay, let's imagine something is at rest. Alright, and we'll just have to believe in that. High beauty of physics. Next, we discussed that why are we applying Newton's laws on Earth then? Because obviously we guys are non-inertial. The Earth is rotating. So everybody on Earth is rotating, and when you are rotating, you're moving in a circle, you have a centripetal acceleration. So you have a compulsory acceleration. The Earth is also revolving around the Sun. Okay. So when you are again revolving around the Sun, you have another acceleration which is directed towards Sun, which is again centripetal. So you standing on Earth, you actually have two accelerations that you can immediately see. Okay, one due to rotation, one due to revolution of the Earth around the Sun. So that means if you have accelerations, you are not allowed to use Newton's laws. Then how is it that we all apply them every day? So the point was, I told you the only problem with your acceleration was, that you see the acceleration of the thing being observed as wrong. Alright. So if something is at rest, it is not accelerating, and when I am looking at it, imagine this body is at rest and I am accelerating with some acceleration A observer. So what do I see? I see this guy accelerating in this direction with A observer, right? So I see an error in its acceleration which is equal to A naught. Now if this already had an acceleration of A vector, again what will I see? I will see the acceleration as vector sum of A vector and minus A vector. I will also add my own acceleration negative side. That is the total acceleration that I will see for this body. Now please notice, so I am always getting this term extra in the acceleration. Alright. But what happens if my acceleration is very, very small? If my acceleration is very, very small. So the options is 2100 upward and 2100 downward. Which one is correct? Okay, so the direction of acceleration is always in the direction of change in velocity. All right. For education, which direction does the velocity change in? It was initially down, it becomes up. So final velocity has become up, the change would be up. That is why the acceleration would be up. Okay. So please remember that the only reason why we can use Newton's laws, yes, we can use Newton's laws on Earth is that because Earth first of all is non-inertial, but we consider it to be inertial due to its small acceleration, and hence we choose to ignore the errors in all our calculations. All right. So I told you you can try this. If you remember the centripetal acceleration is omega square r. So what is the acceleration of Earth? Earth has an omega which is 2 pi over 2400, 24 into 3600. Right? Earth is taking 24 hours to complete one rotation, which is it rotates by 2 pi. Good evening, Samarjit. How are you? So Earth rotates by 2 pi degrees in every 24 hours. 24 hours is 24 into 3600 seconds. So omega of Earth is this. This is the omega of Earth. So if you square this and if you multiply it with the radius of the Earth, alright, then this is the acceleration that you get because of rotation. Then if you add the acceleration due to revolution also, revolution, the omega would be even smaller. Why? Because in revolution, the Earth is completing 2 pi degrees in 1 year. Alright, so revolution omega would be 2 pi over 365 upon 24 upon 3600 whole square into the radius of the orbit, of course. Alright, so that will become even smaller than this, way smaller than this. That can be ignored in front of this also. And if you calculate this, I told you that this also comes to about this amount. So the acceleration of Earth is around 0.035, alright, 0.035 meter per second, which I can say for all practical purposes, I can ignore this. Alright. And the error in my calculations due to this would be almost so small that I can practically ignore this. So all the scientists said, okay, you know, we know that we cannot apply Newton's laws on Earth, but then what do? So it's better to have something with a small error than not to have anything at all, right? That is the only reason why you are applying Newton's laws on Earth, because its acceleration is so small that practically you can ignore it and you will be fine. All right. Next, of course, I talked about this also, that Newton's laws also cannot be applied for microscopic particles. For this, you will have your quantum mechanics, and for objects which are moving with very high speeds, you will have relativistic mechanics. Another very interesting point which I did not mention the last time. Again, so let's just highlight this. This is also very important. You should always remember this. That in case of microscopic particles, you just won't be able to apply Newton's laws in any case. And similarly for objects moving with very high speeds comparable to c. Again, but that also does not happen practically, so that is why we are fine. If these two cases arise, then also I won't be able to apply Newton's laws. And now, biggest of all, the laws, Newton's laws are always identical for all inertial observers. Alright, so this is another important point that I wanted to discuss. Okay, now please remember this. This is very interesting. Okay, so I'm getting rid of this. And this I had already discussed in the last class. Okay, why is this not going? Okay, now it went. Alright, so let me get rid of this. Now let me tell you one thing. That when you're looking at a body, and I told you, if two observers were looking at the body, and one observer was at rest and one observer was moving with a constant velocity, v observer. Alright, both are inertial observers. For both, F equals ma equation would look exactly the same. For both, even if this guy if has some acceleration A, it has some force acting on it which is F. All right. So let's use some other color for that. So if it has a F vector acting on it, due to which it gets an acceleration A. Aaron Kapoor says, can we use work energy theorem when forces are non-conservative? Yes, work energy theorem can always be used, but not energy conservation, Aryan. Aryan, work energy theorem does not care whether forces are conservative or not. You cannot use energy conservation if forces are non-conservative. Now let's rock, sir. Let's solve some problems. All right. So first, this is also very important for all inertial observers. The equation of Newton would remain the same. This guy would also use this equation, F equals ma. This guy would also have the exact same equation. So you should remember this. For all inertial observers, the equations of Newton's laws never differ. They are always the same. All right, that brings a very interesting point. Okay, so if imagine there are two observers, one is at rest and one is moving with V. All right. Now, when this guy sees things, he will say that I am at rest, and observer 1 says that observer 1 is at rest and observer 2 is moving away with V. What happens if you ask observer number 2 what is happening? What happens if you ask observer number 2 what is happening? Observer number 2 says that I am at rest and it's the observer number 1 who's moving away with V. So imagine both these observers will claim that they are at rest and it's the other observer who's moving the opposite way. Alright. Now it turns out there is no way to settle this dispute of who is correct. There is absolutely no way to ascertain who is correct. That is a very interesting fact in physics. That two inertial observers can go on arguing. One will go on saying that I am at rest, 2 is moving. 2 will always say that no, I am at rest and you are moving, and there is no way to settle this dispute. No matter what they do, even if they perform all the experiments of Newton, all the results would be exactly the same for them. Alright, any experiment of physics would be exactly the same for them. So they cannot realize actually what happened. Who is the one who was at rest and who was the one who was moving. So that is a very interesting fact. Again, we will discuss that someday in detail. For now, let's go ahead. And I wanted to tell you that, as I said, Newton's laws are only defined for point masses. Then why are they useful and how are they even useful to us? Because point masses are hypothetical quantities, right? Point masses are hypothetical. They are imaginary. Then how do we apply? What use are Newton's laws to us? Right. So how can we use them? So it turns out there is a special case. There is a special case when we can apply. So I told you, you apply them on big blocks. So you say that there is a big block and it has a force F. Yes, Pawan. So in fact, on Plus, I had taken this session about how nature has this conspiracy of you never knowing about your own velocity. You can never know about your own velocity. You can know about your acceleration, by the way. You can never know about your velocity. And that was the entire basis of Einstein's relativity. Einstein was forced to think that if nature does not want you to know your velocity, it will do everything to hide your velocity from you. Alright. So one of the postulates of special theory of relativity, by the way, was that speed of light for every observer is c only. Imagine that is a very strange result. Imagine an observer which is at rest and there is a light beam. So somebody switched on a torch. So there is a light beam that is traveling. So observer at rest will say that light is moving forward with c. Now there is another observer who imagine himself was moving with c by 2. You know what he will say when he looks at this light? He will say that this light is moving forward with c. Can you do one-shot sessions on mechanics, sir? Yes, I have already done that. If you go to the Unacademy app, you will find one-shot sessions on mechanics, on Newton's laws, on work power energy, and on momentum. All right. On rotation, of course, I couldn't make a one-shot. So I'm trying. I've made a two-part video, but no, three-part. But I think I still left out a small topic. I had to. All right. So this is something very interesting. This is what Einstein said, that even for somebody who himself is moving forward with c by 2, when he looks at the light, he should also feel that light is moving with c. Otherwise, he will know. Okay, I was moving, and this guy was not moving. Right. So the point is, it is. You should not be able to know whether you are moving or not, as long as you have a constant velocity. All right. You should not be able to know. Why Newton's laws are hypothetical? Newton's laws are not hypothetical. Newton's laws are not hypothetical. Sir, if theory of relativity is proved, then put it in all textbooks. Okay. So first of all, yes, relativity has been proved. It is in all your standard textbooks, by the way. It is in all your standard textbooks, not for your class 12th syllabus, but you take up any standard book on physics. You take up H.C. Verma, there is a chapter on relativity. You take up Resnick and Halliday, there is a chapter on relativity. You take up university physics, there is a chapter of relativity. Relativity is there in all the textbooks, Pawan. It is just that they never included that in your class 12 syllabus. That is why you don't study it. Not a part of your syllabus. But in every physics book, you will always find it. Okay, so Prabhat Anand, why not real or like quantum mechanics, quantum physics? Okay, so Newton's laws are very, very real. Are very, very real. In fact, quantum theory started as hypothesis. All right. So as I was saying, if it's not Newton's laws that are hypothetical. Newton's laws are defined for point masses, and point masses are hypothetical. Alright, I didn't say that Newton's laws are hypothetical. Newton's laws are defined only for point masses, and point masses are hypothetical. Yes. So, and I had told you the trick that imagine if you have a bigger body, alright, instead of a point mass. So, what happens is that chapter 47, the special theory of relativity, yes. Alright, you will have that chapter in every physics book, by the way, because it is a proven theory, it is the correct one. So as I was saying, that even if you have a big mass, you could have considered this to be made up of many small point masses. So let's give them names. I am calling them, okay, this point mass, maybe I'm calling him M1. I'm calling this point mass M2, M3, M4, and so on. So I'll give names to all the point masses. Alright. And now I see that why are they sticking together? In this, you realize there are many point masses. So when I pull this guy is also moving forward. Why is this guy moving forward? So somebody must be pulling it. I did not pull this. So who is pulling this? The masses which are near this. Alright, so this part which is right next, this is pulling it along with him. So these forces are called internal forces. Okay, we will talk about that later again in detail. But the point is that every point mass in this body may feel external force which I am applying. It will also feel internal forces due to every other point mass. So this point mass, this guy moved because other masses are pulling it, because I am not pulling it. I am only pulling this part. Okay. So my force is only acting on this. So what is causing the acceleration of this? The force due to the adjacent points. Similarly, if I imagine, if I pull this here, okay, and rotate this. If I am rotating this, I am only rotating this part. Why is this part accelerating? This part obviously is accelerating. Why? Because it is moving in a circle. If it is moving in a circle, so this part accelerated, which means there must be a force. Because without force, there cannot be an acceleration, right? That is what Newton's law is saying. So if I just move this very fast, from start, so this force, this part is accelerating. So every part is accelerating, but I am only applying force on one part. So the reason why this guy is accelerating is because all the neighboring masses, all the neighboring parts are applying forces on it. They are keeping it together. That is what is keeping the solid in shape. Imagine, because gravity is pulling this down. Why is this not going down? Because the nearby atoms are keeping it up. Alright. So what happens is, now if I start writing the forces that every mass is feeling. So for M1 I can write, so for M1 I can write that M1 feels a force F. Okay. So that is the force that I am applying. So let's say F external vector plus M1 must be feeling some force due to M2 plus M1 may be feeling some force due to M3 plus M1 may be feeling some force due to M4 and so on. So I will write the force that M1 is feeling due to all M2, M3, M4 or till M infinity. Okay. Now when I add these up, what does Newton's law say? Now this is a point mass. M1 is a point mass. Okay, so I can apply Newton's law for this. Okay, so here I don't have a problem. This would be M1 A1, where A1 would be the acceleration of M1. Alright, similarly for M2, so this is for M1. For M2 now I can say that M2 doesn't have any external force acting on it. Alright, let's take a look at M2. What is M2 doing? Alright, so here is your M2. It is not being acted by any external force. The only force it can feel is due to the neighboring masses. Alright. Now, by the way, even if some neighboring mass is not applying a force, then the value will come out to be 0, so you don't have to bother. So this would be force on 2 due to 1 plus force on 2 due to 3 plus force on 2 due to 4 and so on. So I will write all the forces on M2 due to all these point masses, infinite point masses. So I will write an infinitely long equation and I can equate this to M2A2. Again, this is a point mass, again M2. So I can use F equals MA for this also, right? Now imagine I go on writing this equation for M3. It will be F on 3 due to 1 plus F on 3 due to 2 plus F on 3 due to 4 and so on. Again, this would be equal to M3A3 vector. Now I will write infinite such equations for every point mass. Imagine I'm writing infinite equations and now I'm adding them. Now when I add them up, what happens? Now something special happens. When you're adding them up, you will realize that this and this will get cancelled. Okay, so this and this will get cancelled when you're adding them up. Why? Newton's third law. What does Newton's third law say? Alright, so according to third law, F on 1 due to 2 should be equal to minus of F on 2 due to 1. Alright, these should be action and reaction pairs, which means that F on 1 due to 2 plus F on 2 due to 1 would be 0. Now similarly you will realize that the sum of this and this will also be 0. So let's mark them with the different colors. This and this would also be 0. Alright, then of course sum of this and this would be 0. So what is happening is that for every force that the masses are applying amongst themselves, you will find the action-reaction pairs in these equations. So when you are adding them up, all these forces which are due to the masses internally will get cancelled out. Alright, so please remember that. So on the left hand side of the equation, the only thing you will have left is the F external, because everything else, trust me, will cancel out. So on this side you have, if there were more than one F, then summation F, otherwise F external. And on the other hand side, you will have M1A1 plus M2A2 plus M3A3. Now is a special case. Now we consider a special case. In a special case, if what happens if the acceleration of all these point masses is same. See, I told you there is one special way in which I can move this pen. If I move it like this, now every point is traveling equal distance. Okay, every point therefore will have the same velocity. Every point will therefore have the same acceleration. Only in this special case. All right. So if I move it like this, such that all the masses have the same acceleration, then what can I say? Then I have a very special case. Okay, so if a1 vector equals a2 vector equals a3 vector equals an vector, so all the point masses have the same acceleration, which let me call a vector. Then I will get if external equals m1 a vector plus m2 a vector plus m3 a vector and so on. So I can take a vector common. If I take a vector common, what do I get? I am getting f external equals summation of all the masses into a vector. Now summation of all the masses is nothing but the total mass of the object. So ma. Now please remember, so this is a special case when turns out this equation becomes true. Alright, so otherwise we will talk about center of mass. If that does not happen, then we can't use F equals ma. So you can use F equals ma only in one special case for larger objects. If all the masses that constitute your system are moving with the same acceleration. And that is when you can say that it has an acceleration. You can only define one acceleration for this in a very special case when all the masses are moving with one acceleration. Alright. So please remember this. So this is an important result. If all the masses move with a single acceleration, move with the same acceleration, now trust me, you need to understand this right away because this is going to be the basis of a lot of tricks. Okay, so if all the masses move with the same acceleration, then all such masses can be considered as a single unit, can be considered to be a single unit, and F equals ma can be applied for this unit. Now this is a very important result. Alright, please remember this, that the only reason why you were applying F equals ma for big objects was you only do that in one special case if all the masses that make up this body move with the single acceleration. Alright, so if they start moving like this, then they don't have single acceleration, then you can't apply F equals ma. Physics wala. Yes, I've heard of him, of course. I don't know him. I did not know about him before I started teaching online. But here, yes, a lot of you guys told me, and that is how I know. Not beyond that. Why? What happened? Okay. So as I said, I had absolutely no idea about what happens online. Like 2 months back, till June, I had absolutely no idea about people are teaching online also, and so many students are studying online. I was in offline institutes. I only knew about the offline system. All right. So in July, when I got on board with Unacademy. I got to know about the online education system, and then only, okay, you thought I might be knowing why. Why did you think so? Okay, not really. It's not necessary. Like so, there are so many teachers all across India. I don't think me and Felix Wala have too many things in common in any case. We don't come from the same college. We don't come from the same place. And I am probably way older than him. I'm guessing. All right. I think I might be 6 7 years older than him. When from what I have come to know, Physics wala, I think he completed his engineering in after 2010, right? Sometime after 2010. I've been to HBTI Kanpur, by the way. I've been to IIT Kanpur. All right. No, 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 not really. I mean, I never had the chance to, talk to him. All right. As I said, I've been to his college though. I think he's from HBTI Kanpur. So I remember in my second year, third year, I'd gone to IIT Kanpur, and I used to have friends in HBTI. I had batchmates in HBTI, so I'd gone there. But again, when I went there, he was probably not even a student there. He joined that institute way later. All right, I'm way old. All right. Anyhow, let's focus on the topic here. Ah, but why would I give a controversial statement if you're asking if I know somebody or not? Either I know somebody or I don't. Anyhow, so now let's focus on problem solving strategy. So now if you are clear about how to what your laws are, now let's see how we will apply them. So this is a standard set of steps that you follow. All right, these are standard. Always stick to this and you will never go wrong. All right. So first you select a system. Whenever you have to solve a problem, as I said, you can select a system of particles because you obviously do not have point masses. All right. So here I can take this as one system. All right. So I will be analyzing this. So that is what my system is. The system is the part of the problem on which you want to focus on. What to do with inorganic? I don't know, honestly. All right, so first of all, you select a system on which you're going to focus, then study the system. How do you study the system? You identify all the forces acting on it, contact or non contact. Then you draw a free body diagram. All right, then you choose a set of axes and you resolve all these forces along these axes. So, appropriate coordinate axes. Please remember, you are free to choose any coordinate system, any set of coordinate axes, depending on what will benefit you the most. So, if I'm studying motion under gravity, if I'm studying vertical motion, so I generally choose, like, I would like to choose this as X and Y or projectile or anything generally, but that does not matter that I have to compulsorily choose this. You know, I can tell you about this interesting problem. So in projectile, in the institute that I was teaching before, they had asked somebody to take the y and the x axis as this. They said take the x axis as in the direction of initial velocity of projection and then solve. So you can do that. You can do that. Turns out the choice of axes will not change your answers, obviously. It's just that measurements would be different of lengths and everything. Your coordinates would be different, but your answers would be again the same. If you wanted to measure the maximum height from here, it would still be the same. If you wanted to measure this distance, this would still be the same. It does not depend on the coordinate system that you choose. All right. Anyhow, so in general, what we are going to do is that suppose if I have to solve a problem of a block along the incline, in that case we would like to choose our x and y like this because it is just convenient. Again, you can still stick to vertical and horizontal axes, but again, as a matter of convenience, generally we choose such a system. All right, so please remember that. So you can choose any coordinate axis, resolve all the forces along these, and then Then you write F equals MA equations for all these directions. So you write summation Fy equals MAY. You write summation Fx equals MAX. And you write summation Fz equals MAZ. Alright, so you write these equations. Then you identify constraints, if any. Now, what are constraints? As the word suggests, a constraint is a restriction. It's a restriction in motion. All right. So, for instance, if this pen is kept here, this pen cannot go down. So, the constraint in its motion is that it cannot have an acceleration in the negative y direction. So, constraint equation is a mathematical equation defining that limitation in the motion of the object. All right. So, the constraint equation for this would be that ay would be 0. Alright, it will not have y acceleration if it is moving like this along the surface. Now, once you have written all these equations, now all you need to do is solve these equations and find the unknowns. Alright, so let's get started then. Pawan has been waiting for this. So, we will start with very simple problems. So, here you've been told that two blocks of masses 5 kg and 10 kg are kept in contact on a smooth horizontal surface, and a horizontal force of 30 Newton is being applied on the 5 kg block as shown. You'll find out the contact force between the blocks. So let's go ahead and solve this. Let us go ahead and solve this. Alright guys, so tell me what do you think would be the contact force between them? So you should give me the answer right away, by the way. You should be giving me the answer right away. This is a very easy problem. What will be the contact force between the two blocks? Alright, is anybody trying, by the way? Please write trying in the chat if you're trying this. Or Pawan and Vineet, were you only interested in fighting among each other? When it comes not in solving problems, is it? Okay, weird. So let's see some answers. I'm going to give you guys 1 minute. If you don't solve this in 1 minute, if I don't get any answer in 1 minute, I am going to solve this. But I want you guys to try it first. Alright. So hurry up, give me an answer. Ten. No. 10 is wrong. No, Pawan. 10 is the wrong answer. What are you guys saying? What has been asked? Find out the contact force. The answer is 20. 20. Okay, so let's see. Okay, so let me just quickly tell you. So there are two ways of solving this. Yes, 20. So there is a red block and there is a green block. So let's talk about the two ways of solving this. And then I'll show the power of understanding the fact that, as long as the accelerations are same, you can consider system units as one system. So in the first analysis, what we do is, so there are two ways. Either you take this as 5 kg and 10 kg. Now, the first step, remember the first step. Again, whenever you're solving the problem, go through these steps. So select a system. So first, let's select a system. Now, here is the trick. I could have gone about selecting the system in many ways. I could have either selected both of them as my systems. So I can either choose this as my system at one point in time. Then for next part, I can choose this as my system. Or what I can do is I can also choose both of them as my system. So first I need to decide what kind of system I want to choose. Whether I want to take 5 kg into my system, whether I want to take 10 kg of my system, or whether I want to take both. Now remember, because they are touching each other, the constraint in their motion would be that they both would be moving with the same acceleration. Alright. So if I have these two in contact, you realize that these two have to always travel the same distance. Alright. So this pen and this phone always have to travel the same distance. If they have to travel the same distance, they have to have the same velocities, they have to have the same accelerations. So since they have to travel with the same acceleration, I could have chosen the system as containing both of them also. Again, by the same logic, please remember this. That is why I laid emphasis on this. That all the masses that move with the same acceleration can be considered to be a single unit, and F equals ma can be applied for this entire unit. All right. So let's try and solve this for two different methods. So in the first method, so let's try this with the help of method number one. So in method number one, I will take both the 5 kg and the 10 kg masses differently and then solve my problem. So let's take a look at the FBD of 5 kg first. So 5 kg is feeling FBD of 5 kg. Again, 5 kg has two contacts, alright, from the ground and from this. So let's say from the ground it feels a normal force N1. From the other one it feels a push of N2, and it is feeling a normal reaction of 5G, and it is feeling a force of 30 Newton in this direction. This is the FBD. You were applying a force of 30 Newton on this. Alright. So this is what the FBD of 5 kg block would look like. So what can I say? What can I say for this? I can say 30 minus N2 equals 5 times A. I don't know what that A is, but I can write this F equals ma for x direction. Again, for y direction, I'm not really bothered, so I won't be writing those equations. Similarly, let's draw the FBD of this other guy, the 10 kg block. So for 10 kg block, it will feel the reaction to N2. So it will feel N2 like this. It will feel its own mg, which is 10g, and then it will feel some N3 from the ground. Alright, so it is in contact with the block and the ground, so it is feeling these forces. So this is the FBD of 10 kg block. Now for this, in the x direction, again, what can I say? For this in the x direction, so this is my equation number one. For x direction, I can say N2 equals 10 times A. Alright. So all I need to do is I can add the two. So equation 1 plus equation 2, what will that give me? That will give me, when I add these two, I will get 30 equals 15A. So therefore, I get A as 2 meter per second square. If I substitute this into in equation 2, then what do you get? You will get N2 equals 20. So that is the correct answer. I don't know what you guys were doing. You were telling me 10. Okay, so this is the method number one. Now method number two, obviously it saves you two steps. It saves you two steps. In method number two, what you do is you take this as the system. 5 plus 10. 5 plus 10 is your system. Alright. Now what you do, you make an FBD of this. You make an FBD of this now. So you say, okay, so you have a single unit of 15 kg. It is feeling a push in this direction of 30. Now, it will feel a downward force of 15g, and it will feel a net n from the ground, let's call it n. This is what the FBD of the single unit will look. So now it is very, very simple. From here you can directly say 30 equals 15a, which you got in the third step here. You realize something that you got after making two FBDs and in the third equation, you are getting here by making one FBD and in the first equation. So what that does is that reduces your time of calculation. So from here you already get A equals 2 meter per second square. Now, of course, now because you have to find the force between them, now you have to separate them. So now you have to make the diagram of 10, and for 10 you will say that N2 should be equal to 10A, which is 20 Newton. Alright. So always remember, you can keep using this trick, you can keep using, keep including multiple masses into your system as long as those multiple masses are moving with the same acceleration. So from now on we will only do that. So here is another problem for you to practice. So three blocks are kept on a smooth horizontal surface. These are connected with a light inextensible string as shown in figure. You have to find out A, the acceleration of these blocks, and B, the tension in each string. Alright. So hurry up, let me give me an answer very quick. So hurry up with this. What is the acceleration of each block? And what is the tension in each string? What is T1 and what is T2? So let's hurry up. Pawan says acceleration is 2, which is fine, which is correct, of course. So yes, you should get a hang of this. Now acceleration calculations should be very fast. Okay, Vinay. Acceleration calculation should be very fast. Now you know when these are moving, because they are tied with strings, they will move with. Okay, so he says T2 is 40. Yes, 40 it is, absolutely. And T1 is 10. Correct. Pawan has got all the right answers, which is good. And that is what will happen when you understand how to solve. You understand how all you can manipulate your systems. You can include two in one system. You can include one in one system. All right. Or you can take all three also in one system, and that will help you save time. All right. So you will definitely need some practice, because this is probably something you would not get used to immediately. But with some practice, trust me, this would be very easy. So yes, Pawan has already given the answer. So I'm only going to show you this by considering all of them in one system only. Now I know that, okay, so I know when these three will move, all three would move with the same acceleration because they are tied with the string. Okay, so this is 10 kg, this is 15 kg, this is 5 kg. So for the first part what I am doing is I am considering this as my entire system. If I consider this as my entire system, now what do I see? So the force here was 60 Newton. So if I consider them as one system, I have a block of 5 plus 15 plus 10, that is 30 kg. And 30 kg is feeling a force of 60 Newton. So obviously the acceleration is 60 over 30, or 2 meter per second square. So the first part is very easy. Alright. How about the second part? Now what I do is, for the second part, I will consider this as my system, only this. So if I consider this as my system, so how do I make the FBD of this? Now I have 5 kg block, it is feeling the force of tension only, which is T1. So for this I can say T1 equals 5 into acceleration, which is 2, or 10 Newton. Alright, because I know the acceleration of 5. No, the acceleration was 2, Vinay. The acceleration is 2. Now for T2 what I'll do is, okay, so for T2 I can take both of them as one system. So if I take both of them as one system, no, acceleration is 2. What are you saying? If I take both of them as one system, now what do I see? Now I see a 20 kg block which is feeling a force T2. Alright, I hope you can see that. So this entire 20 kg is feeling a force of tension, which is T2. So now T2 would be equal to 20 into 2, which is 40 Newton. So there you have all the answers in single lines. If you can choose your system wisely in every problem. So remember this. Get some practice and start choosing your system wisely. The moment you start choosing your system wisely, the problem solving would be very, very easy. I hope you could see that from here. So for finding the acceleration, I chose my system to be consisting of all three masses. Then for T1, I just chose 5 kg block. Then for T2, I chose both the blocks. All right. See, I can write, I can draw the individual FBTs of three, write 3, 4 equations and solve them. Yes, that will also work. But that will usually take you longer. So this method of taking, coupling a lot of masses as one system will always save you time. Now let's try another problem. So two blocks of masses 7 kg each are connected with a light inextensible string are pulled upward with a force of 120 Newton. Okay. So now find out the acceleration of the blocks and the tension in the string. Now this should be very, very easy. Okay. Yes, now you should be getting a hang of this. All right. So solve this very, very quick. So what will be the acceleration of the two blocks? You can take G to be 10. Take G as 10. Yes. Take the value of G to be 10. Acceleration is 0 and tension is 70. Absolutely correct. So again, very, very simple. You know that these guys will move with the same acceleration 7 and 7. Alright. So if they're moving with the same acceleration, what I will do is I will take both of them as one system. So if I take both of them as one system, then what I have is I have a single block of 14 kg. You have 140 Newton acting up. You will have mg, which is 14g acting down. Okay. All right. Now I know since G has been told to be taken as 10, so the net force is 0. The net force is 0. F equals this would be 14. 14A. So that tells me A is 0. All right. If A is 0, now what I can do is I can consider this. If I consider this, if I make an FBD of this, all right. So now let's take this as my system. So what are the forces that this guy is feeling? 7 kg. It is feeling some tension T and it is feeling 7g. And since the acceleration is 0, since A equals 0, I can say T should be equal to 7g or 70 Newton. All right. Can I ask you one question? For education, I'm sure you are again confused about something in kinematics. So the tension is 70 Newton. Okay, so all right. Next, we will discuss about Atwood machine problems. So Atwood machine is nothing but a pulley. This is called an Atwood machine, by the way. All right, this is just a fancy name to the pulley. All right, so this again is a huge class of problems where a lot of questions you will see of Newton's laws. All right, so let's take a look. Let's see how to solve these problems. So here I have taken an example that two blocks of mass m1 and m2 are tied to a string. Yes, for education. Tell me. I will try and answer right after this. Okay, so for education, and I will give you an answer. I will give you an answer, but I hope you realize that this is not a doubt class. I need to cover some syllabus that I have planned. So let me do that, and after that I will definitely tell you, but I cannot answer too many questions during the lecture, alright? Because it ends up wasting everybody else's time. Because there are so many students here who are here to study Newton's laws. Alright. So I have to respect their time also. Alright, so here in this problem you've been told that two blocks of masses M1 and M2 are tied to a string and hanging from a pulley as shown. Okay, so this is a very common, this is a simple Atwood machine problem. Alright, this is the most simple setup that you will see, and you have been told you have to find the acceleration of the blocks and tension in the string. Now you've also been told to consider the pulley and the string to be idle. Now I hope you remember what that was. Ideal string means, ideal string is, so what is ideal string? So massless and inextensible, which means you can't stretch it. Inextensible. So that is what a massless, an ideal string is. An ideal pulley is massless and frictionless. So please remember this. Whenever you see ideal pulley in your in your problem, so that means your pulley has no friction and it has no mass. All right. Please remember this. The Newton's law of motion PDF link not available. Yes, I uploaded them in the morning today. All right, I just uploaded them from my end in the morning today. The team would upload, will make you the links, will make the links available to you very very soon. All right. So now, how do you solve this problem? So there are again two methods of solving this. Either you make the FBDs of M1 and M2. So once you've made the FBDs of F1 and F2, now you imagine that M2 is going down with acceleration. Now, because they are both connected to a string which is inextensible, which means it cannot stretch, this guy will be going up with the acceleration A. Alright, now in this case, this is the string constraint, by the way. This is the constraint in their motions. Whenever two things are connected with a string, they are bound to just move with the same velocity along the length of the string. Alright, so if one end of the string moves x, then the other end also has to move x because the length of the string cannot change. Alright, so in the first method, again, what I'll do is I will use the regular methods of solving, and then I will show you a shortcut. So in the first method, let's talk about this method number one. So method number one. In method number one, I am writing the F equals ma equations for them individually. So if you look at this, and I said that this is going up with A. So what can I write the equations as? I can write T minus mg equals m1a. Alright. So T minus m1g equals m1a. That is the first equation that I can write for mass m1. Now, what about mass m2? Mass m2 is being pulled down and this string is pulling it up. Okay, so here it is. Here is the FBD. And this guy will go down with acceleration A. So the net force downward should be equal to m2a. So for this I can write m2g minus t equals m2a. Now what I need to do is I can add both these. If I add both these, what I'm getting? So 1 plus 2. 1 plus 2 gives me m2 minus m1 g equals m1 plus m2a. Alright, so I'm getting my a as m2 minus m1 over m1 plus m2 times g. This is what I get my acceleration as. Now that I have got my acceleration, it's very very simple. The tension would be, I can substitute this value of A in any one of those. So T would be m1 times g plus A. That is from equation number 1. Alright, so what is this? Let's see. So m1 times g plus A is m2 minus m1 over m1 plus m2 g again So I can take this G common, and if I take these things here, you will realize what I will get is after solving. This is what I get. I will get T equals M1 M2 G over M1 plus M2. This is what I will get my answer as. Again, you don't need to memorize these. This is how you solve this. I wanted to show you method number one. This is how you solve this. Okay. I hope it's clear. Okay. So there will be two M1 M2 G. All right. So you can check the calculation. You can solve it. This is how you get it. Thank you for giving free education with super faculty, sir. Okay, no problem. You can thank Unacademy for this. See, all right. I am getting paid by Unacademy for this. All right. All right. So now let's take a look at method number two. How do you solve this in a shorter way? All right. So now let's talk about method number two. Alright. In method number two, I know that along this string, both the masses have the same acceleration, right? So what I'll do is, instead of this, I will imagine the two masses kept like this. Alright. And this is M2, this is M1. Imagine that this guy is being pulled on this side by M1G and this guy is being pulled on this side by M2G. Alright. Hi Swami Narayan Bhakt, I'm good. What is my code? My code is RD Live. I hope you should know. You should know by now. It is RD Live. All right. All right. Great. So now, please remember that since these are like this, and one guy is being pulled down, one guy is being pulled down. So what the MGs are trying to do is move them in opposite directions. All right, M1G is trying to move both the masses in this direction. M2G is trying to move both the masses in the opposite direction. So I can just simply make this as my setup, and you realize that this appears to be the same. The answer for this would be the same as that. Now I know I can take both the masses as one system. Why? Because both my masses are going to move with the single acceleration. If I take both of them as one system, then what I have is I will have an FBD where I have this M1 plus M2 mass. On one side it is being pulled with M2G, and on the other side it is being pulled by M1G. Now you realize it is very simple to find the A. You can do it in a single step. Your acceleration would be the net force. The net force would be M2 minus M1 times G over the total mass, which is M1 plus M2. That is it. In method number two, you get the answer for acceleration in a single step. Alright. So remember this trick. This trick will help you solve all your pulley problems very fast. Now, of course, for T also, you could have written this equation and then substituted the value of A here. So that would still remain the same. But A you are getting in a single line. And here you got your A in this step. Alright, so that is the advantage of this. Now, why don't you try this in one of the problems? So here you've been told that two blocks of masses M1 equals 6 kg and M2 equals 2 kg. Okay, it's not working. Okay, that is strange. Why is it not working? Why is it not working? It's not giving you 10% off. So maybe use RDSC. It should work. Or you can try this. Discount would be 10%. This code should work. At least that's what I've been told, that it is supposed to work. So otherwise you can use this RDSC. You can try this also. It's saying error. Okay. Okay, I don't know. I will talk to the team about this. All right. So yes, Pawan is very very right in this answer. So in this question you had two blocks, only 10, because it's not me who's giving you the discount, by the way. You are not paying me the money. You're paying Unacademy the money. They decide. I don't know why only 10. Yes, only 10. That is what. See, the fees is already very less. The fees is already very less. You are getting 10% off on top of it. I hope you realize. The fees is already very very less. Okay. Trust me, I have taught at offline coachings for 8 years. All right, all offline coachings charge anywhere between 6 to 12 times of the fees that you are paying here. All right, so in any case, I can't. I don't have the code. I don't have any other code. They just told me that this is your code. See, for 10% also you have so many codes. You have so many codes for 10% also. This is just my code. If you want to dedicate your subscription to me, this is just your way of saying that you like my teaching and you want to dedicate your subscription to me. That is why you're using this code. Otherwise, you can use any code. Almost every code you have gives you a 10% off. Yes, that definitely I can assure you. That I can assure you. If you attend all my classes, if you work hard also, then of course you will be able to crack it. All right, so Pawan is giving me all the answers. He says 30 Newton. All right, so let's see. Again, very very simple. So the masses are 6 and 2. So here this is being pulled by 60 Newton. This is being pulled by 20 Newton. So I can just make the FBD of this as take them as one system of 8 kg. So this becomes 8 kg being pulled on one side by 60, on the other side by 20. So the net force is 40. So acceleration would be 40 over 8, alright, which is 5 meter per second square. Apply 10 teacher codes to get 100% discount. Yes, you can take 10 subscriptions, of course. So you realize you can find the acceleration in this single step. Now of course it is very very simple. You can write the equation for anyone. For m1 you can write that this was feeling down 60, t up. So you can write that 60 minus t should have been equal to ma would have been 6 into 5. So from here you would have t equals 30 newton. All right. So yes, that is, those answers are correct, Pawan. Well done. So I hope you're getting a hang of this. Okay. Now why don't you try this problem? Okay, again, this is a variation, but this also you can solve in a single step using the trick that I just told you. That is the great thing about the trick. It will work here also. All right. All you need to do is consider the force that is pulling. Consider the force that is pulling. Okay, so not Minty, but okay, I will conduct a quiz very very soon. Okay, it will be on the app. Okay, so we have been told by Unacademy that they have prepared a platform for quizzes, which is supposedly better than Minty, and we have been told to take all the quizzes on the Unacademy app. All right, almost everyone has offline coaching, but due to pandemic, they had moved online for some period. Yes, okay. Yes. This is the last problem that I'm discussing. This is the last problem that I'm discussing. So, guys, just solve this very, very quick. Solve this very, very quick. Two blocks of masses m1 equals 6 kg and m2 equals 2 kg. m2g by m1? No. No. Yes. Okay, so see, here this guy will get pulled by m2g. So M2G is trying to cause the motion, M1G is not trying to cause the motion. Here you don't have anything pulling this. Alright, so you need to find the external forces that are trying to cause the motion. So if you take them as one system, alright, thank you, Vinith. Okay, I don't know why this is here, so let's forget about this. All I'm saying is, since both these guys will also move with a single acceleration, I can always take them as one system. So if I take them as one system, M2 and M1, this guy is feeling pulled because of, okay, so M2 is this one. So this guy, remember, is feeling pulled by a force M2G, and this guy is not getting pulled anywhere. So if I take both of them in one system, what do I have? I have one mass of 8 kg, which is being pulled at one end by 20 Newton. Alright, because yeah, M2 was 2. So now I can say that acceleration would be 20 over 8, which is 2.5 meter per second square. I don't even need to solve the equations. You can solve the equations later, but you can give the answer in single step. Again, consider them both as one system. Now think, what is the force that is trying to cause the motion? I don't know, Swami Narayan Bhakt. Alright, so this is the last problem that I wanted to discuss. Once you know this, then of course you can find the tension, but very easily make the FBD of this. If you make the FBD of this now, alright. Let's see when the government decides to open them. Alright, if you take the FBD of this now, then you have a straight line, one line equation, that is T equals, so M1 is only feeling T. M1 is only feeling T, right? So T equals M1 into A. So T would be equal to M1 was 6, A was 2.5. So that will be 15 newtons. So those are your answers. Okay. I hope you followed this. Why? Okay, so that is it. This is my time for today. I hope you guys like this trick. Practice this trick. Trust me, you will save a lot of time. All these kind of problems, pulley problems, you will be doing within 1 minute. All right. So you can go and try your HC Verma now. Try all these problems, and trust me, you will save up a lot of time using these tricks. All right. So again, this also you could have done. Again, what are the forces which are going to be pulling these blocks? Mg over here, and here you will have capital Mg sine theta. All right. So now you should know the trick. How to calculate acceleration. The acceleration would be net force pulling, which would be Mg minus Mg sine theta over M plus M. Alright, single line answers for so many problems. Alright, you find one force is pulling both in one direction, another force is pulling both in another direction. You find the net force in any one direction divided by the net mass. Alright, so please remember this. So that is it. That is where I would like to wrap it up for today. You guys practice some problems and see the wonder of you being able to solve all the problems in one steps. All right. So for education, okay. So for education, could you you said body falls from a height of 200 meter. The ratio of the distances traveled in each 2-second duration during. Okay. So body falls from rest, I hope. Every problem for me would be for 2 minutes. Okay, so t equals 0, it is here. Then t equals 2, t equals 4, and t equals 6. Alright. So here let's call this S1, S2, S3. Alright, so first thing that you will know immediately is that S1 equals half G into 2 square. Alright, that is the distance that the ball travels in the first 2 seconds. Alright, so this is coming out to be 20 meter. Okay, next, now consider what is this height. If this is S, then the ball has come down S in 4 seconds. So I can say that S equals 1 by 2 G into 4 square. Right. So this is 16 by 2, 8 into 10, 80. So therefore S2 would be S minus S1, which is 60 meter. Alright. Now again, if this is S dash, then S dash would be 1 by 2 G into 6 square, sorry. So that is 36 by 2, 18 and into 10, 180 meters. And if I can subtract S from S dash, then I'll get S3. S3 equals S dash minus S. So 80 minus 180 minus 80, so that is 100 meters. So now S1 is to S2 is to S3 is nothing but 20 is to 80 is to 100, which is 1 is to 4 is to 5. Okay, so 1 is to 60. That is what. So 20 is to 60 is to 100. So 1 is to 3 is to 5. That is your answer. Okay, for education. Okay, are you happy now? Let me know if you followed this. So let me put it on the side a bit so that you can see. If you followed this, then I would like to wrap it up for today because Abhinav sir's class is also about to start. And I also need to go. For education, is this clear? Okay. So I'm hoping it is clear. Even if it is not, I have told the answer from my side. All right. Okay. How you divide? How do you take ratios? Take 20 common, no? Divide everything by 20. Divide everything by 20. So divide all of them by 20 in ratio. How do you calculate ratios for education? Divide all of them by 20. The ratio has been asked. No, how do you calculate ratios? I think you need to study maths first before you want to try your physics. Yes. Okay. Alright. So that is it. Now I'm not going to take any more questions. So now before I leave you, let me remind you that you should be getting your Plus subscriptions as soon as possible. And the way to do that is go to the Plus section, select your goal as IIT JEE and click on Get Subscription. Alright. Please remember to get your subscriptions as soon as possible because the prices are going to get hiked up after 10th of September. Please remember, this is what the prices look like right now till 10th. Alright. So, a 1 month subscription, again, not much use to you guys. I think for all class 11th guys, you should focus on this subscription. So, for you guys, the 2-year subscription currently comes at 36,000, which if you use this code RD Live, it will come down to 32,400. Alright. So this is what you should be getting and get it fast because after 10th, this subscription becomes 56,000 from 36,000. This is after 10th. Alright. Even after the code, it will be more than 50,000. So get your subscriptions as fast as possible, as soon as possible. You do not want to pay extra for this when you can get it for a lesser price. All right. So please remember to use this code. This is my code. Use RD Live to get your subscriptions. All right. Okay. No problem. Now, if you like today's video, if you like the tricks that I'm telling you, then press the like button and share it with all your friends. Again, for those of you who can't afford this paid subscription, also paid courses, also we are giving you free content here. But of course, I can't individually give too many people too much time here. In the courses, what happens is that you are attending my regular classes. There, I will keep a regular tab on your progress. There, I will be mentoring you for 2 years, next 2 years, on a regular basis. All right. So that is what the difference between here and there is going to be. But in any case, Unacademy wants as many students to benefit from or get access to quality education as possible. Even if they can't get the subscription, we are giving out these videos for free. Share them with as many people as you can so that more and more people have access to free quality education. The PDF of all the notes, slides used in today's lecture would be available for download within 2 days. All right. Now, for those of you who are following us on the JEE English channel, don't forget to connect with us on the Telegram app using the link above. And before I go, use this code RD Live and get 10% off on your next Unacademy subscriptions. All right. So I'll see you now next week. So till then, you take care. Yes, yes, yes. You are right. You are right. All right. I'll see you guys next week. Till then, you keep revising, you keep practicing, and take care. Bye bye.